Hello, hello, welcome back everybody. Please welcome to the stage Stephan and why and how CloudStack.
Exactly.
Stephan.
Thank you. Thank you. And I would like to follow Rohit's call this morning for more users talking about that they use CloudStack, how they use CloudStack, what we actually do with it. So I'd like to share the story of weSystems, how weSystems went ahead and decided for CloudStack, and what we actually do with CloudStack, and how we do it. I think that's really that's a great story for all people looking into which of our orchestration to use. Being at the same position as where weSystems has been 4 years ago, deciding of which way to go, which path to follow, and setting the strategy with that. weSystems, where we are founded in 2017, we're a purely European company and have locations mostly in Germany and Bulgaria, Burgas at the Black Sea, and we are a managed hosting service provider, and we provide hosting services and communication services. When I started at weSystems 4 years ago, roughly around four years ago, there was virtualization, of course. There were managed hosting services based on the likes of Proxmox, for example, based on the likes of VMware. But we set a new strategy, and we wanted to go a step ahead, purely focus on hosting services. And we felt that the existing technologies did not meet the requirements we were receiving from customers, from new projects. And that's why we thought about, okay, let's define our requirements to cope with the requirements of our customers, because that's all what we do, is focusing on customer requirements, solving challenges of our customers. And we needed a new tool set. We needed a new infrastructure, a new set of, a new cloud infrastructure, so to say, a new orchestrator. And we set the requirements in the likes of, we were already focused on open source. So everything we can, or wherever we can and wherever it makes sense, we try to build an open source project. We are convinced by that is the right way. Same as we have it here, a lovely community, great interaction, and we can actually interact as well. We can contribute as well. And that's, I think, a true value for that. And at that point in time, we had customer environments sitting on VMware. We had internal services sitting on the likes of Proxmox. But I felt like one platform, deciding for one platform, can be such a big benefit. One platform for our infrastructure as a service offering, one platform, the same platform for our managed hosting portfolio, and the same platform for our own services, which we have to run for weSystems. And we will have a talk for that, I think, tomorrow as well, combining hardware of different generations, combining old hardware, new hardware. There are tools out there which do not require the latest, greatest, most up-to-date hardware, which are running perfectly fine on, let's say, 5 years old hardware, perfectly fine, and hardware is still running. So let's use that. So combining all of these requirements in one platform gave discussions within the team as well. Team members asking, well, but it's currently perfectly running fine on a BC, and but there's a phrase called eat your own dog food, or in other terms, use the services you actually sell or provide to your customers. That's, I think, where the true value is of using one platform, when every one of our team is using the same platform as our customers are using. We gain more experience with that. We learn to work across challenges we are facing in the platform, and we notice issues the same as that. So having one platform for our services, which we use, and the services we provide to our customers, I believed in that, and over the time we figured out, the team figured out as well, That's the right choice we made. Multi-tenancy. Multi-tenancy is a requirement which is a base for many of those other requirements. Multi-tenancy in the term of multiple customers using the same platform. We, as weSystems, being a customer to our own platform, using the same platform. So multi-tenancy was a really strong requirement. Ease of operation and ease of use. And we heard that from Rohit this morning already as well. I think that's where we're quite a small team managing the platform, managing customer platforms, managing our own platforms, and deployment should be an easy thing. Updates should be a quite easy thing. No one should be scared to update a platform. When we are scared to update a platform, then something is wrong. And something went wrong in the very beginning of planning or integrating the whole setup. Whenever there's an update, and we tested that in testing environments already, there should be no fear of updating your production environment. Should be. So we made that a requirement, and ease of operation comes with ease of usability as well. We have a lot of customers which are not yet in the cloud, or which were in the cloud at a hyperscaler and felt like this is too complicated. I just want to spin up a VM and I have to read a whole book of documentation just to spin up a simple VM. And this ease of use, well, we made it a requirement. Multi-data center support being one of the requirements, because we already had and still have a data center in Berlin in Germany and a data center in Amsterdam in Netherlands. So both data centers being in the European Union, and we wanted to keep it like that to provide customers with easy possibilities to to build resilient platforms, to build disaster recovery platforms. So multi-data center support should be included in the new tooling as well. And hybrid solutions, as I mentioned, we have a lot of customers being co-location customers or starting as co-location customers. Customers who still run dedicated hardware for various reasons. Not yet jumped to a cloud yet, or operating appliances which are not available as virtual appliances as well. I'm thinking of the communication part of the communication product portfolio of our offering. There are sometimes appliances which do not exist as a virtual appliance still, and combining those. So being able to operate or to deploy and operate a hybrid solution, a virtual and a cloud solution based on the future orchestration layer, and combining those with our co-location customers, combining those with with dedicated hardware, with physical hardware. And these were the requirements we actually set. And we thought, like, which orchestration layers, which virtualization layers are we going to compare? We knew Proxmox. We already ran Proxmox, so Proxmox was in the game still. We knew VMware. So VMware, we took plain VMware into the evaluation as well. And well, we heard a lot about OpenStack. OpenStack at that time, 4 years ago, was a big name. It still is, but at that time, wherever we went, we heard about, oh, you're using OpenStack. No. So OpenStack, we thought, like, let's add OpenStack to the evaluation as well. And CloudStack. How did I come to know CloudStack? We heard this morning, CloudStack is not that well-known that well-known name. It's not all across the world. I used to work with Alex at our previous employer, and there we already used CloudStack. So I knew CloudStack could actually maybe bring the benefits we're looking for, and added that to the tooling. And none of my colleagues ever heard of CloudStack, which is what we heard this morning, spreading the word about CloudStack. And well, I wouldn't be here if we didn't choose for CloudStack. Yeah, in the end, we chose for CloudStack. It is open source, which, for example, the VMware is not, which was still in the game. It is open source, and well, looking through the user list, looking through the GitHub issues, through repositories, the community is fun. The community is so much helpful, and whenever you see an issue, whenever you feel like there's a need for something else, you can raise issues, and it's treated with respect and it's treated with value. And that's really what makes it great to work with CloudStack and with the community around it. One platform, or being able to provide most of our services from one platform. So CloudStack perfectly serves the purpose for our infrastructure as a service offering. We have the possibility to create domains, to use different service offerings. We are able to combine old and new hardware with different service offerings as well. And different clusters, different service offerings to be able to use old hardware, new hardware within the same platform, and provide all those services from one platform. Multi-tenancy being the base for example, being one platform or providing only one platform. Multi-tenancy, I mean, when you look at CloudStack, having domains, having accounts, having users, having even projects, I think there's not a lot more you could wish for, and that enables us to create customer accounts. To actually, we provide the same. We provide the plain CloudStack UI to our customers. It's perfect for that purpose, and we can have customers logging in directly to the CloudStack UI. And multi-data center, well, with CloudStack zones, that's an ease. And now even with edge zones, broader, making the use cases even broader, even wider. That's a great tooling for that. Ease of operation. We only have those two components. We have the management. Well, simplified. We only have those two components. We have the server, the management server, and we do have the agent on the hypervisor. That's it. And thinking of OpenStack, for example, when we try to evaluate that, I think once we were finished reading through all the components required to run an OpenStack, we already had the CloudStack POC up and running. That's a great difference and great benefit. And the team actually was I could see during the POC already, I could see the team getting creative with CloudStack, seeing the tool set of CloudStack which is provided. Thinking in solutions, thinking of, oh, I can combine X, Y, that. I can solve the challenge X, Y, that with the tooling. That's exactly what I wanted to see. Seeing engineers being creative, getting creative again, and having that rich tool set of CloudStack is exactly fulfilling that. And just last week, well, a bit behind, but last week we updated to 4.18. It was easy. And none of the engineers are scared of updating the CloudStack platform. Of course, we test that before, but after the testing, no one is scared to put that on production as well. And that's really great. And the hybrid solutions, well, layer 2 networks, or in general, the rich set of different network offerings. We mainly use layer 2 networks, for example, with that, being able to specify VLANs in your layer 2 networks, connecting colocation customers, connecting platforms outside CloudStack with CloudStack, and being one platform for the customer, for us, for the customer. That's great. VPCs with private gateways, connecting to platforms outside out of CloudStack to VPCs. Well, so far we've always been able to connect some platform outside CloudStack with resources inside CloudStack, and that really went well. So we chose for CloudStack. It was quite a quick choice, I have to say. Once we saw the inspiration of our engineers testing CloudStack, we saw the creativity which was brought up using CloudStack. That was an easy go for us. And so I mentioned we use CloudStack as one platform for most of our service offerings. We use it for our infrastructure as a service offering. So we have customers just using plain resources in our data centers. Well, we spread that across Berlin and Amsterdam. So we have customers logging into one UI and consuming resources in Berlin and Amsterdam, wherever they need, and being able to connect that with their colocation resources, for example. GPU accelerated cloud, and I have one more slide about that one next. It was not that obvious, but we were able to provide GPU-supported instances using CloudStack, even though we run on KVM and not on, I think, according to documentation, should be Xen, which is supported, but we use KVM, but still, we found a way, and that actually enabled us to fulfill quite interesting use case. As I mentioned, at weSystems, we run hosting services and voice and communication services. And those voice and communication services being quite latency critical, we had no fear of joining that to the CloudStack platform as well. So we run most of our VoIP and communication services from CloudStack across the data centers again. And yeah, we're able to move that from other platforms. Our managed computing services, the likes of being simple as managed web servers, web server stacks, managed monitoring services, which we provide to our customers, and even now with the Kubernetes integration, being able to offer or to provide from that one platform managed Kubernetes clusters. So it's a variety of services we can provide based on the CloudStack platform we built. And that together with the hybrid solutions again, so hybrid in the terms of consuming resources within CloudStack and together with resources outside CloudStack. Let's try that. Yep. So we have a customer which was using already, who was using our infrastructure as a service offering already in our data center based on CloudStack, and that customer actually approached us during the COVID time because they are doing exhibition booth, and they had the experience, well, exhibition booths, physically visiting exhibitions during COVID time, what was not possible. So they invented digital exhibition booths, and they asked us, okay, we are using your cloud already, but we need more. We do have 3D. We do have 3D models. We have customers presenting their 3D models of their products usually, and we are able to already provide those as 3D models. But we want to provide those to our customers, to the end users. And since it's quite intense in terms of client resources, they come up with the idea of render streaming, which renders these 3D models in the cloud, and then it's just presenting the user with a pure image or with a video in that case. That made us thinking, okay, we need GPU-supported instances. How can we actually do that? And as I mentioned, we do not use Xen. We use the KVM hypervisors. And we found a solution at that time. How was it called? Additional VM configurations was not available yet. But we figured out there's the thing called Groovy scripts. So hook scripts we can hook into the deployment of VMs right before the VMs are actually deployed. So we can change the XML for KVM, required for KVM. We can change that, and we can inject virtual GPUs. So we plugged in GPUs into some of our servers, spliced them into virtually multiple GPUs, and then were able to inject those into the virtual machines. And actually, the virtual booths or the digital booths, exhibition booths, went really great, and that actually extended as well to virtual trainings. As we saw in this video, we have products of customers which can be quite intense for repairing. So you have to know about how to repair such products, and they actually made training centers out of that as well. So they give their end customers the possibility to have virtual trainings, but yeah, being able to outline each and every single part of their products, and being able to train people to repair their products. And that's what we actually run on our cloud as well. And that's something special, something where we didn't see the solution in the first run yet. But yeah, that actually worked out really well. And the hybrid solution, and we have more and more of that still. Hybrid solutions where we actually connect customers in the co-location, and we have quite a lot of customers in the same data center as where we run our Berlin zone of CloudStack. And it looks simple. It looks simple cross-connect within the same data center provides a very easy way to connect existing customers to cloud resources. So just using those quite low charging cross connects in the same data center enables our customers to use the cloud resources at lowest latency. They don't have to spend big money on any cloud connect to any hyperscaler. They can simply use the cross connects in the same data center and be connected to our cloud to our CloudStack platform in Berlin and in Amsterdam at the same time, using our backbone in that case. And that makes it very easy for those customers to take the first step to cloud resources, to test their applications at cloud resources. Most of those customers are not planning the big bang migration. Oh, today is everything on physical hardware, and tomorrow everything will be cloud. It's a step-by-step migration and project. And that allows them, with a very simple cross-connect, to start using the cloud, start using our cloud offering, and then, of course, starting most of the time starting with infrastructure service, but then being able to consume more and more of those managed services as well. That's what we do, it's part of what we do with the CloudStack environments, and then on how we do it. I mentioned we have multi-data center. We have a multi-data center platform, which is Berlin and Amsterdam. So both the regions are in European region. We are GDPR compliant. We have a layer 2 connect between those regions, and we run a quite solid VXLAN based backbone between those. And we are using advanced zones. We are using advanced zones and using the KVM hypervisor for that. And using offerings across the zone, so we always use the same, or we mostly use the same offerings across Berlin and Amsterdam for the ease of use for our customers. It's easy for them to decide which offering to go. And we have a few predefined offerings, like small, medium, large side of things. But our customers really value as well the custom offerings, so they can specifically choose amount of CPU, memory, exactly what they need, and are not bound into offerings where they just need a bit more memory, but have to buy more CPU for that as well. On the computing side of things, so we group most of our hosts by generation and by capability. Generation, using combining older hardware and newer hardware, and we use that. We usually have a cluster per generation, and we have then, so that VM migrations only take place within the same type of hardware. And each host has multiple host tags. So one tag being the generation, and another tag being the capability. Capability can be as simple as Windows, no Windows. That's a licensing that really helps us with licensing, because licensing all of our hosts for Windows. Most of our customers use Linux, so it doesn't make sense to license all of our hosts for Windows. And using host tags can be an easy way to direct VMs to the right host. And capability in the terms of GPU as well. So a host with a host tag GPU can then run VMs which need the extra support of GPU. And well, for customers and for us, it's made easy with service offerings, naming exactly those capabilities, naming of Windows, naming of GPU supported, and naming the generation for that. Storage-wise, even before we decided for CloudStack, we already we already built storage clusters based on Ceph. So we purely use Ceph. We have Ceph clusters running on purely NVMe, and we use RBD images for the VMs on Ceph. And as secondary storage, we use Ceph as well, and based on HDDs, on spinning disks, and we present that via NFS currently to CloudStack. And Ceph, NFS, and HostHA gave us surprises, let's say. Usually you talk about happy little happy surprises, but those were not little happy surprises. We tested, we tested we wanted to try HostHA, and yeah, it's supported on NVM NFS so far. I think there's something tomorrow. It's currently supported on NFS only, so we thought, yeah, well, okay, we run NFS on the secondary storage anyway. So we spun up we created primary storage based on NFS as well, and we spin up as many VMs as we have hosts, and then put them into an anti-affinity group, so making sure that every host is running one VM which is running on the primary storage based on NFS. And that worked quite well. We tested a few scenarios, and that worked as kind of as expected, or as we then learned from the documentation how it should work. And then we run an Ceph update, which is a rolling update. One after one is shutting down, rebooting, and so did our CloudStack host, which was not the plan. Once a moment in a Ceph environment, you have at least around 3 hosts presenting those NFS cluster IPs, let's say. And once the currently active Ceph node holding that NFS IP actively was rebooting, which usually is totally fine because another host takes over, well, all of our CloudStack hosts started rebooting one after the other. Hit us really by surprise, and was not a happy surprise. And digging into it, made it really complicated. But we decided, after talking to the guys of Ceph community as well, the Ceph NFS is not really a great fit from our experience for HostHA. We learned that the hard way. Networking-wise, we mainly use isolated networks and layer 2 networks. In all different kind of combinations, we use layer 2 networks as well to present or to provide customers with a public access, which is for public IP address spaces for their appliances. When they don't want to use a virtual router, they have their own firewall appliance, let's say, they have their own local appliance, whatever, we present them with a /29 as an example via layer 2 networks. Kubernetes with Ceph CSI, we're using Ceph, so why not using Ceph CSI for the Kubernetes? But we felt like presenting the Ceph through a virtual router is not what we're actually looking for. So what we actually did, we created an isolated network based on a custom offering, being able to specify a VLAN. That VLAN then was able to communicate with an external gateway. And we put in a reservation in that isolated network to make sure the IP address for the external gateway is not used by CloudStack. And then we simply have routed access to the Ceph. For that, we needed in Kubernetes, we needed a daemon set, so making sure that every node is aware of routes, of the route to the Ceph environment, and deployed host routes. And with that, we have direct access to Ceph from Kubernetes, while keeping the benefits or the integration to the normal isolated network. And on vGPU, I already mentioned that. We started with that, and we kept it for now. We kept it like that, giving us a great possibility for customization using a Groovy script or using Groovy scripts to inject XML data into the deployment of virtual machines. Mentioned that already. Really happy about how I saw my colleagues being inspired to work with CloudStack, being creative again, working on solutions, working on seeing solutions within CloudStack, and that's what really is a big benefit for us at weSystems working with CloudStack. Thank you.
Thank you, Stephan. Brilliant talk. Thank you very much. Any questions for Stephan from the room, real quick? Okay, let's make this real quick because we are at time now. Excuse me, Alex. Come over here.
Hi, I'm Vincent. I'm also from Germany, and first thing I want to say is it's very funny to see someone who stumbled over exactly the same things as we did. I remember trying to figure out the Groovy scripts using ChatGPT to help me, and yeah, the vGPU thing is exactly the same with us. The question I have is, you talked that most of your customers have Linux. Most of our customers have Windows VMs. And we are thinking about trying to build something with AMD and Intel. Are you using only Intel, only AMD? What's your approach with this?
We are using mixed, but in different generations. So as I mentioned, we have different service offerings for different server generations. And within one generation, then it's only Intel or only AMD. But yeah, so far it's mixed.
Thank you. Anything else from the room, real quick? Good, thank you.